Make a Brushbot.
We need to look at this.
Are those googly eyes?
Alright, wait, hold on.
Oh,
We need something scientific.
What do you mean scientific?
Battery, and then we connected these, but it was all way too long, so we had to rearrange everything.
Every year, earthquakes trap people in collapsed buildings around the world. When rescue teams arrive, they face a big challenge. How can they find and reach survivors when the spaces are too small and dangerous for people to enter? We needed to ask important questions like, what tools do rescue teams currently use? What are their biggest challenges? How much time do they usually have to find survivors? By understanding these questions, we could start thinking about solutions that might help save more lives.
When we looked for solutions, nature gave us an amazing answer: cockroaches. These insects can squeeze through spaces as thin as a quarter, move quickly over rough surfaces, and survive in harsh conditions. We started imagining, what if we could build these robots that move like cockroaches? What if these robots could carry tiny cameras and sensors to help find people? What materials could we use to make them? This led us to think about creating small, simple robots that could crawl through tight spaces just like these amazing insects.
Our plan was to use household items and tools available in our science classroom to design a basic robot using these materials: a brush head for the body and movement, a small motor to create vibrations, a cork to attach a motor axle, a battery for power, and wires to connect everything together. We drew detailed sketches showing how all the parts would fit together.
Then we created our first Brushbots by carefully attaching the motor to the toothbrush head and connecting it to the battery. Just like a real cockroach, our Brushbot would hopefully scurry across surfaces using vibration. Our first test was disappointing. The Brushbot only worked for a few seconds before stopping completely. We discovered several problems. While the small 3-volt coin battery had enough voltage for the motor, it did not have enough ampage to make it run for a long time. The bristles weren't making good contact with the surface. Also, once the wires were connected, there was no way to turn it off. We needed to use bigger batteries. That meant a bigger bot.
Through careful experimentation, we made important improvements to our design. We tested brushes of different sizes and found that larger brushes provided more stability but slower movement, while smaller brushes created faster but less controlled movement. Battery choice made a big difference too. 3-volt coin batteries were lighter but had shorter lifespans, while AA batteries provided more power but added weight. 9-volt batteries provided the most power and needed the heaviest brush. A major improvement came when we added an on and off switch, which not only saved battery life, but also made testing much more efficient. Perhaps our most interesting discovery was how the position of the cork on the motor axle affected the robot's performance. Moving the cork up made the bot zip along faster, while positioning it lower created stronger vibrations. We learned that the different cork positions work better on different surfaces, and finding the perfect sweet spot was key to balancing speed and stability.
Brushbot prototype is just the beginning. It represents an important first step toward creating robots that could one day save lives. Through the engineering design process, we learned that solving real-world problems requires patience, creativity, and willingness to learn from failure.
Our next challenge include adding heat sensors to detect body warmth, sound detectors to hear calls for help, and small cameras to see inside collapsed structures.
We know our simple Brushbots aren't ready for real rescue missions yet, but they've taught us valuable lessons about persistence and problem solving, just like Thomas Edison, who failed countless times before creating the light bulb. We understand that each setback brings us closer to success. The future of rescue robotics is exciting, and it all started with a simple toothbrush and an idea inspired by nature.
Motor. Oh no. I got stuck.
What happened?
I got stuck here.
Had shorter lifespans, while AA batteries
Sized bot, and finding the perfect balance was key to balancing speed and stability.
You don't need to go every time you rip it. You're gonna rip it all off.
Go. Go. You can go. Yes.
Okay.
Oh,